In this work, we present REBEL, rule-based and experience-enhanced learning with LLMs for initial task allocation in multi-human, multi-robot teams. REBEL is an enhanced ITA framework designed to handle the complexity of the real world. REBEL has the flexibility to comprehend diverse user preferences, the adaptability to respond to last-minute mission changes on the fly, and it is sample efficient by leveraging contextual knowledge. The first stage in our framework is rule generation, where the LLM generates a set of helpful rules to follow to achieve each user-specified objective. Here you can see an example prompt with three components: the mission description, the goal, and the user preferences. We structured the prompt in our custom SPF to help organize all the information for the LLM. Using this prompt, the LLM generates a set of rules as shown on the right, and they are stored for future use. The second stage is experience generation, where the LLM performs ITA for 10 random missions for each objective to generate experience data. The prompt now also includes the relevant objective-specific rules from stage 1. For each mission, the LLM generates an ITA plan as shown on the right. The ITA plan is deployed in our OpenAI Gym simulator and performance data is recorded. This experience data is used to refine the rules stored in the vector database and is also stored for future use. The third stage is inferencing, where the LLM performs ITA on the actual mission meant for deployment. We introduce a rule-based learning Retrieval-Augmented Generation module that uses an ensemble retriever to extract the most relevant rules from the rule database created in stage 1, given a vector embedding of the user's preferences. We also introduced an experience RAG module, which first embeds the user's mission description and finds the most similar missions from the experience data using cosine similarity. These experiences are then re-ranked based on the recorded reward values. Now the prompt is fully complete and the LLM is well equipped to perform the final ITA. We evaluate REBEL in a real-world scenario, which involves analyzing pollution levels in warehouses. The details of the tasks, robots, and humans for this mission are shown on the right. Here is a demo video of the simulation in action. First, the robots travel to each POI either autonomously or teleoperated by human agents. Pictures of each POI are captured, simulated by a short time delay, and they are then sent to the appropriate human agent or robot for classification. The assigned agent then determines if the POI is a hazard or not. This process repeats until all POIs have been classified. In the first experiment, the user specifies only one objective to be optimized. The results shown here demonstrate REBEL beats or is within 10% of ATRL, the SOTA reinforcement learning approach. In the second experiment, the user specifies a combination of 3 objectives to be optimized with various priority levels. The results show that REBEL is the only approach that accurately reflects user preferences by achieving the highest scores in the objectives prioritized by the user. Finally, we evaluate situational awareness by randomly adding and removing agents to simulate humans getting sick or new robots being added to the team. REBEL effectively addresses these last-minute changes and can serve as both a standalone framework and an inference time extension to further enhance pre-trained RL ITA policies. Thank you for watching.